All right, so we're going to solve systems using the elimination method, and I'll send the notes along with you. Step one is to have the two equations in standard form, which they were given to you in standard form. Draw a line, put a place for the answer. Now, step two, we want to eliminate the variable. Now, this one is very simple, because if I add the equations as they stand, will the x's disappear? Yes. So the x's disappear here. I would add my equations, and I would get y equals a -2, put my answer in here. Now, once I've done that, you start alternating equations. So we'll use our first equation. In place of y, we'll put our -2. And then we'll go ahead and solve this. Now, once we've used one equation to find the variable, now we're going to use the second equation for my check. And again, put your dotted line down here. So I have a -7 times 2 plus a -2. So this is a -14 plus a -2, which is a -16, and it checks. All right, so let me review the process. Standard form. If you can add them as they stand and one of the variables eliminates, great, you can go right on. Solve. Take one of the equations, substitute your answer just like we did yesterday, solve. Then, once you have both the x and y, go back and check it. Now, I know some of you are not done, but I want to skip ahead to number 10, get the notes for number 10, and then you guys can come back. All right, so, are you moving with me? If you look at this first one, as it stands, if I add, will either one of the variables drop out?
No.
Which variable would you like to eliminate, x or y? And it doesn't make any difference.
Y.
So if we're going to get rid of the y, what basically is our common denominator between these two?
5.
15 is the common denominator, okay? Which means equation 1 needs to be multiplied by 1, or it stays the same. The second equation needs to be multiplied by, see, we have a 3 here, so it needs to be multiplied by 5. When you multiply your equations, make sure you multiply each and every piece by that same value. Now, once you have multiplied the two equations, and again, you can always multiply by 1. Look at the equations. If you add, will one of your variables cross out? If it does, you've eliminated those. So if I add here, I get 12x equals 132, x equals 11. Once we get one variable, now we go back to how we did it yesterday. You take one of your equations, and I'm just going to take the top equation. It doesn't